ओके गाइस, अब हम फटाफट चैप्टर 3 फिनिश करेंगे. So firstly, we'll study about the interior of the earth. Now, the interior of the earth can only be understood by indirect evidences because no one has been able to reach the interior of the earth. Basically, whatever is the configuration of the surface of the earth, it is mostly a product of the processes which are operating in the interior of the earth. There are two types of such processes, the exogenic processes and the endogenic processes. Now, okay, so the Earth's radius is 6,370 kilometers. Now, we have to know about the information about the interior of the Earth. We have two types of sources. One is the direct sources and the other one is the indirect sources. So firstly, the direct sources. Now, the gold mines which are in South Africa, they are as deep as 3 to 4 kilometers. Now, beyond this depth, it is very hard to go because it is very hot at this depth. But still, scientists, they are working on two major projects. One is the Deep Ocean Drilling Project and the other one is the Integrated Ocean Drilling Project. As a part of these projects, the deepest drill was done at Kola in Arctic Ocean, and that was to a depth of 12 kilometers. One more source for direct information is the volcanic eruption, because when that molten material, which is magma, which is thrown onto the surface of the earth during the volcanic eruption, then we can use that for some laboratory analysis and we can study, but still it is very difficult to ascertain the depth of the source of that magma. Now let's talk about the indirect sources. We know temperature and pressure keep increasing with the distance from the surface as we go into the interior depths. Also, the density of the material also keeps increasing as we go into the interior depths. We observe that the material and the structure which is observed in meteors, it is similar to that of the earth. So meteors are also another source of information about the interior of the earth, and the other indirect sources are gravitation, magnetic field, seismic activity. Now, how? We'll discuss that. Now we know gravitation force is not the same at different latitudes on the surface of the earth. We know that it is very great on the poles and very less at the equator. Why? Because the distance from the center of the earth at the equator, it is much greater than at the poles. So gravitation force is much less at the equator than at the poles. Now, this gravity is influenced by many other factors. At different places, it's different. Why? Because it's influenced by many factors. So these readings they differ from the expected values. Such a difference is called gravity anomaly. Now, this gravity anomaly is very crucial because it gives us information about the distribution of the mass of the material in the crust of the earth. Now, magnetic surveys also provide some information about the distribution of the magnetic materials in the crustal portion. And so they also provide us some information about the distribution of materials in this part. Got it? So these are all the indirect sources. Now, let's talk about earthquake. So, why does the earth shake? The release of the energy, it occurs along a fault. What is a fault? A fault is a sharp break in the crustal rock. These rocks along this fault, they tend to move in opposite direction. But the overlying rock strata, they press them. The friction locks them together. But their tendency to move apart at some point, it overcomes the friction. As a result, the block gets deformed and eventually they slide past one another very abruptly. This causes a huge release of energy, and these energy waves they travel in all directions. The point where this energy is released is called the focus of an earthquake, or alternatively, it's also called the hypocenter. Now, these energy waves, they travel in different directions and they also reach the surface. The point on the surface which is nearest to this focus is called the epicenter. It is the first one to experience these waves on the surface. It is the point which is directly above the focus. Now, what is lithosphere? Lithosphere is nothing but the portion which is up to a depth of 200 kilometers from the surface of the earth. We know about an instrument called seismograph. The seismograph records the waves which are reaching the surface. Now, earthquake waves are basically of two patterns or two types. They are body waves and surface waves. Now, body waves are generated due to the release of energy at the focus, and they move in all the directions traveling through the body of the earth. That is why they have the name body waves. So these body waves, they interact with the surface rocks and they generate new set of waves which are called surface waves. These waves, surface waves, they move along the surface. Now, the velocity of waves changes as they travel through materials with different densities. Remember, the denser the material, the higher is the velocity. The direction also changes as they reflect or refract when coming across materials with different densities. Now, there are two types of body waves. They are called P and S waves. Now, P waves, they move faster. They are the first to arrive at the surface. That is why they are also called as the primary waves. These primary waves, they are similar. P waves, they are similar to sound waves. They travel through gases, liquid, solid, everything. Now these S waves, they arrive at the surface with some time lag. That's why they're called secondary waves. Now the important fact about S waves is that they can only travel through solid materials. This characteristic is very important. The surface waves are always the last to report on the seismograph. But these waves are more destructive. They cause displacement of rocks and hence the collapse of structures occurs. Now, we'll talk about the propagation of earthquake waves. As they move or propagate, they cause vibration in the body of the rocks through which they pass. P waves, they vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of the propagation. As a result, it creates density differences in the material, leading to stretching and squeezing of material. And the other types of waves, they vibrate perpendicular to the direction of propagation. The direction of vibrations of S waves is perpendicular to the wave direction in the vertical plane. Hence, they create crests and troughs in the material through which they pass. Surface waves are, as you know, the most damaging waves. Remember, okay? Now, the emergence of the shadow zone. So these earthquake waves, they get recorded in seismographs which are located at very far off locations also. However, there exist some specific areas where these waves are not reported. Such a zone is called shadow zone. Now, it was observed that these seismographs at any distance within 105 degrees from the epicenter, they recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degrees from epicenter, they recorded only the arrival of P waves but not S waves. Thus, there is a zone between 105 degree and 145 degree from the epicenter, which is called a shadow zone where both the waves are not reported. So, basically, the entire zone beyond 105 degrees does not receive S waves. So, the shadow zone of S wave is much, much larger than that of the P waves. Why? Because the shadow zone of P waves is like a band around the earth between 105 degrees and 105 and 145 degrees away from the epicenter. While the shadow zone of S waves is not only larger it is also a little over 40% of the Earth's surface. Now we'll talk about the different types of earthquakes. The most common type is the tectonic earthquakes. Obvious, these are generated due to the sliding of rocks along a fault plane, and there is a special class of tectonic earthquakes which is sometimes called as the volcanic earthquake. These are confined to areas of active volcanoes. And in the areas of intense mining activity, sometimes the roofs of underground mines collapse. So it causes some minor tremors. These are called collapse earthquakes. And the next type is the explosion earthquakes, which is this ground shaking. It can also occur due to the explosion of some heavy chemical or nuclear devices. These are called explosion earthquakes. And the next is the reservoir induced earthquakes. What happens is in the areas which have large reservoirs, some earthquakes occur. Reservoir induced earthquakes. So we have tectonic earthquakes, volcanic earthquakes, collapse earthquakes, explosion earthquakes, and reservoir induced earthquakes. Now, how do we measure earthquakes? We measure either according to the magnitude or according to the intensity of the shock. According to the magnitude, it is measured on Richter scale. What do you mean by magnitude? Magnitude means the energy released during the quake. Now, this Richter scale, it is expressed in absolute numbers between 0 to 10. Now, you can also measure the intensity of the shock. It is measured using Mersali scale. It takes this intensity scale is nothing but it takes into account the visible damage caused by the event, and the range of this intensity scale is from 1 to 12. We'll talk about the effects of earthquake in